All right, welcome to Unit 3, Lesson 1, beginning of our study of perfect competition. This stuff brings us to really the heart of the AP Microeconomics curriculum, so I'm excited to get it started with you. In class, we started off by talking about the assumptions of what makes a market perfectly competitive. So to review those with you, every firm in a perfectly competitive market has a very, very small market share, so that they essentially have no ability to change the price on their own, no market power, we would say. They sell a standardized product. Every firm's product in pure competition is identical. The consumer is indifferent between one company's product over another one because they're the same thing. The firms, therefore, are all price takers. They take the market price and just have to sell all of the units that they want to sell at that price. They won't price higher because nobody would buy theirs, and they won't price lower because they don't need to sell all they can make. And then the firms have free entry and exit. So today, in this first lesson, all three of these are going to be significant. We're going to see what effect that has on the firms. Mainly what we're going to look at first is their decision of how many units of the good to produce, and given different market prices that they have to take as price takers, how they make that decision, which comes down to what's going to be my profit maximizing output, and that's why we call this the profit maximizing decision for a perfect competitor. So we're going to start off with an analysis of a situation where a perfectly competitive firm, PC will stand for perfectly competitive from here on out, and that it's got a certain cost structure, which is shown by this total cost column. We see that. I've already filled in the marginal costs. Should be very familiar with how to find that at this point. And now the new piece to add to the puzzle is the firm's revenues. We're going to say that this is a tomato farmer, and the market price of tomatoes is $18. Let's say this is per pound or whatever. So at $18, we would say for the first pound of tomatoes, their total revenue is $18 times 1 pound is $18 total revenue. If they sell 2 pounds of tomatoes, they're going to get $36 of total revenue. Our total revenue is simply equal to the price of the good times the quantity of it sold. We've seen that before. So the rest of this column just multiplies 18 by the quantity of tomatoes that are sold. Now the new concept here is this thing called marginal revenue. We're going to find marginal revenue the same way we found marginal cost. It's equal to the change in total revenue over the change in the quantity of output. So from 0 to 1, the company gets $18 in marginal revenue or additional revenue for selling that first unit. From 1 to 2, it gets the difference between 18 and 36, $18 of additional revenue. From 2 to 3, it gets, look at that, $18 of additional revenue. You're starting to see a pattern here. The marginal revenue for this firm is going to be $18 all the way through. Each of the first 7 units of output at least, and for a perfectly competitive firm we would say this would go on for all the output it can produce, gives it the same marginal revenue. They sell $18 worth of additional goods by selling an additional unit. That's another just way of saying this comes from the fact that they are price takers, and they're such a small part of the market that they don't affect the market price by selling more. So we would say that if we graph this, make this quantity of output, and this the price or the cost. At $18, we'd call this their marginal revenue curve. We even say marginal revenue curve even though it's a straight horizontal line. The marginal revenue is a horizontal line at the market price of the good. This is because it's a price taker and because it can sell all it wants for that market price. We would also say, and our book doesn't make this as clear as they want you to on the AP test, this is also called the individual perfectly competitive firm's demand curve. So the perfectly competitive firm's demand curve, the firm's demand curve, is perfectly elastic. Remember, a horizontal line is going to be perfectly elastic at the market price. We're going to call that their demand curve, again, because they can sell all that they want at that market price. It's not like they have to drop the price to sell more. Again, because they're such a small part of the market, they can sell out all they want without affecting the market price. Okay, so there's an introduction to that marginal revenue concept, which is really key to understand. Okay, now we've got marginal costs that we've already got figured on this column. And what we're going to try to fill in here is what are the different amounts of profit that the firm will make depending on how much it produces. This will change because even though the revenue stays the same for each unit, their cost changes for each unit they produce. As we've already seen why that is, because of diminishing returns and all that kind of thing. So the profit is simply total revenue minus total cost. We can see that for the first, if they produce 1 unit, their profit is 18 revenue minus 30 cost. They're going to lose money if they only produce 1 unit. And we can take that all the way down. If they produce 2 units, their total revenue is 36. Their total cost is 36. Profit of 0. If they produce 3 units, $10 of profit. If they produce 4 units, 72 minus 56. $16 of profit. 5 units, 90 minus 72 is $18 of profit. 6 units, 108 minus 92. Here's where the pattern you might be thinking is happening breaks. Now the profit goes down to 16 if they produce that 6th unit. And then for 7 units, their profit is back down to 10. Okay, so again, I just found that by subtracting the total cost column from the total revenue column for each of the different options. We can think of these as all the firm's different options of quantities of output to produce. So what's the firm going to choose? Well, obviously the firm is going to choose $18 as its profit maximizing level of output. Note that profit max. And we'd say that they're going to produce all the way through. They're going to keep producing up through 5 levels of output, and then they're going to stop. And it's that amount there that gives them their profit maximizing output of 5 units. Okay, so to find this on a graph, or to find this on a table, we're going to be able to find the profit maximizing output of a firm plus its amount of profit, amount of loss, if that's the case, on a table, and then we're also going to have to do it on a graph. To find it on a table, you could go through and just do this every time and calculate the amount of profit from all the different units of output shown and just find the biggest one like we did before. But that's there's a shortcut, and it's actually more important to understand it in this way in terms of a marginal analysis as the best way to do this. And this is also going to allow us to do it with a graph without even any numbers. And that's to take the rule of, and go down to the next slide, that the firm should keep producing until either the marginal cost is equal to marginal revenue or until the last time when marginal cost is greater than marginal revenue. So let's take a look at how that shows up on this table. Notice that for each of these units of output, I'm going to check the boxes we're comparing here. For the first unit of output, first tomato, the marginal revenue that the firm is getting is 18. The marginal cost of that tomato is 16. As long as the marginal revenue is greater than the marginal cost, the firm is making money on that unit of output. So yeah, they're going to produce the first unit of output. Second one, 18 versus 6, definitely yes. Third one, 18 versus 8, yes. Again, with each of these, they're making more money than they're spending. They're taking in more than they're spending, so they're adding to their profit each time. And with the 5th unit of output, 18 versus 16. Now here's where it changes. If they decided to produce a 6th unit of output, their revenue from producing the 6th unit would be 18, but their cost of producing the 6th unit would be 20. Focusing on these two right here. What that tells us is that we've reached a point where if they keep producing, they're going to start subtracting from their profit because it costs them more to produce those units than they bring in revenue. So that's another way to analyze, here's why they should stop there. Even if we didn't have this profit, if we didn't go through and find the profit of every unit of output, we'd be able to tell what the profit maximizing level of output was just by finding here's the last unit where the marginal revenue is greater than the marginal cost. And that's at 5 units of output if the price is $18. And again, they're going to take the market price. Okay, so there's a key concept there is that the profit maximizing rule, the the most simple way to think about it is they're going to maximize profit if they're producing where marginal cost is equal to marginal revenue. Now when you're dealing with the table, notice there are no units of output where marginal cost is exactly equal to marginal revenue. So kind of what you want to do is like the last one that doesn't go over, the last one where marginal cost is not above marginal revenue, and then stop there. Okay, that leads into how do we show this on a graph. What this graph is simply a graph of the data in this table. Specifically, the marginal revenue line, which we already showed above, is horizontal, perfectly elastic at the market price. And the marginal revenue curve, which is given by this, the marginal cost curve, which is given by this column here. Notice that it's a nice standard U-shaped marginal cost curve, reflecting some specialization at the very beginning and then mostly diminishing returns in terms of productivity later. And we would say that where these two cross, the profit maximizing point is again where marginal cost is equal to marginal revenue. And when you graph these out and when you graph your marginal values in between the x-axis values, then it should line up that that's at that 5 units of output, which is your profit maximizing output. So why is this? Let's think about what is happening if the firm is not producing 5 units. If the firm produces 3 units, let's show that on the graph. At 3 units, here's the marginal revenue and here's the marginal cost. Marginal revenue is greater than the marginal cost. And we can say that they're leaving profit on the table. They're leaving this profit here unearned by not producing more units of output. If they produce a 4th unit of output, they would still have revenue greater than the cost. They should go ahead and keep producing until those marginal revenue and marginal cost curves intersect. Again, if they're producing less than the profit maximizing level of output, then marginal revenue is going to be greater than marginal cost, and they should keep producing until those become equal. On the other hand, if they're producing 7 units, at 7 units, marginal cost is greater than marginal revenue, and they've gone too far. They've subtracted from their profit. They've produced to the level where the costs are growing higher than the revenues, and so they should reduce output until marginal cost becomes equal to marginal revenue. Okay, so there's how you do this with a simple graph, and you should get real familiar with, okay, so this is the standard graph of a perfect competitor in the short run. You can call this quantity and this price is the simplest notation that works. This is the marginal revenue, which is equal to the price, which is equal to the firm's demand. And then here's the marginal cost curve. And the profit maximizing level of output is where marginal cost crosses marginal revenue, call that Q star. And that's it. Just those are the standard shapes for a perfect competitor's marginal cost and marginal revenue and profit maximizing quantity. Without any numbers, we can tell that's the profit maximizing quantity. Okay, now we can get more specific about the firm's profitability, both with the numbers we've been given and on graphs. And again, what you want to be able to do with the tables, with numbers, is to be able to calculate the amount of profit or amount of loss. The firm might be in a situation where the best they can do is produce at a loss, so you want to find the one that loses them the least. So be able to find that with numbers or on a graph. So we're going to show both here, how to do it both with numbers and with a graph. So let's start with, here's another table that just takes the same data that we had up in this table and then extends it into to find the average variable cost and average total cost, because we're going to talk a little bit about the relationships of those and the firm's profitability. But let's just start with it by talking about how the profit would change if the price were different than $18. Okay, so I'm going to erase all of this here. Sorry if you've marked yours up like mine. Big mess. And let's change the given price, the market price. Let's say for whatever reason the market price changes. Say the price now is $14. Okay, if the price is $14, again, we got to fill in our marginal costs here to find this. Now our total revenue numbers are going to change. 14, 28, 42, 56, and so on. Our marginal revenue is going to change to be 14 each time. Remember, the marginal revenue is equal to the market price of the good. So just by looking at this, you should be able to tell, okay, what's the how much should the firm produce if the market price is 14? Let's go down and make sure, okay, should they produce, ignore places where at the beginning where marginal cost is falling, they're never going to produce in the decreasing part of marginal cost. So let's keep going to, okay, so here's the point where marginal revenue is greater than marginal cost, they should produce that one. Again, marginal revenue is greater than marginal cost for that one. And marginal revenue is greater than marginal cost for that one. Now when you get to the fifth unit, now with the price being 14, now marginal cost is greater than marginal revenue, so they should stop. The profit maximizing quantity should be 4. And now if we figure their profit from that, if you got total revenue of 56, total cost of 56, their profit is 0. They're breaking even. That doesn't sound as good as last time, but remember the price has changed and the company can't change the price. So given a price of 14, this is actually their best situation. If we were to go through and calculate all the other profits, they're all negative. I'm not going to do that, but if you went through and did it, 0 is actually your best option. So they're breaking even if the price is 14. Now let's do one more, and then we'll take these down to the other slides. Say that the price is equal to $10. Again, let's erase all this. Those can stay. Okay, so at a price of $10, we've got 10, 20, 30, 40, and so on. We got marginal revenue 10, 10, 10, 10. And now, looking at the table, can you tell how many units of output we should produce? Answer is 3. That's the last one where marginal revenue is greater than marginal cost. And their amount of profit, which is just total revenue minus total cost, is negative $14. So they have a loss of $14. You could even say a loss of $14 or a profit of negative $14. It means the same thing. But again, that's their best situation. If you went through any of these other ones, they're worse. Negative 16, negative 16, so on. Okay, so now let's use all 3 of those scenarios, prices of 18, 14, and 10, to make some general rules about profitability relative to a firm's cost and the market price. So here's the summary that we're going to find up top. If the market price is greater than the average total cost of production, and I'm even going to put one more thing on this, it should be the minimum average total cost of production, then the firm is going to be making a profit. If the price is equal to that minimum average total cost, the firm breaks even. If the price is less than it, then the firm incurs a loss. So why is that? Let's do a quick proof of that. I hope we'll drive this home. If profit is equal to total revenue minus total cost, we can also then divide each of these by the quantity of output and say that the average profit, sometimes called the profit per unit, is equal to the average revenue minus TC over Q we've seen before. That's average total cost. Now, average revenue is also equal to the price, the market price of the good. If the price is $14 per unit, the average revenue they receive from selling each unit of the good is equal to $14, just the price. So the average profit is equal to, just replace average revenue with price, P minus ATC. Therefore, if P is greater than ATC, then profit is positive. If price is equal to ATC, profit is 0. And if price is less than ATC, profit is negative. Okay, so on the graph, you can see here that our average total cost of production, which aren't going to change depending on the market price. Those are just your costs. Remember, our marginal costs above didn't change. Our average total costs for the firm are not going to change depending on the market price. Here's our average total cost curve. The minimum average total cost is $14. And note, when the market price was $14, we said that the firm produced 4 units and broke even. When the market price was $18, then the firm produced 5 units. If the price was $18, the firm produced 5 units. The average total cost of production of those 5 units was $14.40. We're not always going to produce the minimum average total cost amount. 5 is still the profit maximizing quantity, but 18 is greater than $14.40. So the price was greater than the average total cost. It was also greater than the minimum average total cost. And then when the price was $10, the quantity we produced was 3. The average total cost was $14.67. $14.67 is greater than 10, so price was less than average total cost, and therefore the firm was incurring a loss. So those are rules that will hold true. To find out, is a firm going to be profitable, one shortcut is to just say, okay, what's the minimum average total cost for that firm? If the price is above that, the firm is going to be profitable. If the price is below that, the firm is going to make a loss. If the price is equal to that, the firm will break even. Let's look at how that works on a graph. 3 different graphs here, one for each situation. We'll start with the P equals $14. Price is $14. If we graph the firm's average total cost, now we've added that to the equation of these graphs. Note that at the profit maximizing output, it's also the minimum cost output. We know that because the marginal cost crosses through the ATC right at that point where marginal cost equals marginal revenue equals ATC. That's the firm breaking even. Marginal cost is equal to marginal revenue, which is equal to average total cost, all at that profit maximizing output. And you should be able to, if asked, okay, draw a perfectly competitive firm breaking even. Start with marginal revenue, quantity and price, add marginal cost, and then draw in ATC just tangent to that point. And that's the perfectly competitive firm breaking even. Now let's take the first example we started with where the price is $18. The profit maximizing point quantity is 5, where marginal cost is equal to marginal revenue. Now we can illustrate the profit on this graph. Now ATC is not tangent to this point. Price is greater than ATC. We can illustrate that by this distance here. EZ, not sure if that's coincidence or not, the way textbook set it up, here is equal to the average profit per unit, which is 18 minus 1440, which is equal to 360. Again, the average profit per unit we can find as price minus average total cost. Price is 18, average total cost of producing 5 units is 1440. Once again, we're not producing at the minimum average total cost. That's not our most profitable point in this scenario. Anyway, if that's the profit per unit, then the total profit we can just take by multiplying the average profit per unit times the number of units. In other words, this area here, oops, should be at 1440, not 14. Let me undo that. This actually does not cross through point C, which is the minimum average total cost point. So this box represents, this area represents the firm's profit if the price is $18. And if you found the area of that box, it would be, let's take it all the way back up, the amount of profit the firm was earning when the market price was 18. I erased all this already. But the profitability would be equal to the area here, which is 360 times 5, so $18. Okay, so the general kind of method, here's kind of what to remember. If you are asked to show a firm's profit on a graph, to show profit, here's what you're going to do. First, take the MR equals MC point here at E. Then drop a line down to the ATC here, that's Z. And then extend that over to the y-axis, like I did twice. And then that marks out your area of profit. Key thing is starting at the right place, starting at this MR equals MC point as the upper right corner of your profit box. All right, we can do a similar thing if the firm is losing money. If the firm's losing money, now the marginal cost equal to marginal revenue point is going to be below average total cost. So we just go in reverse. Find the MR equals MC point, extend a line up to the average total cost, and then extend that over to the y-axis. The average total cost of producing 3 units is $14.67. So the area of that box, we've got a loss of $4.67 per unit times 3 units is equal to a loss of $14, which we already saw above is the amount of loss that's going on here. But again, that's their best situation given the market price of $10. In the next lesson, we'll figure out, okay, what does it mean when the firm long-term is losing money? Then nobody's going to be in business to lose money, right? And the answer is they won't. But there's a difference in the answer to that question between whether we're talking about the short term or the long term. It has to do with fixed cost, as you might expect. It has to do with economic and accounting profit. And we'll get into all that in the next lesson. So for now, this wraps us up in finding the firms, perfectly competitive firms, profit maximizing output and price and amount of profit. And we'll do several problems with this to make sure you get the hang of this in class before we go on.